Okay, ladies and gentlemen, this is the last part. I would call this part 3 of the reproductive system, specifically discussing the female reproductive system. So I was made aware that I had a few missing slides, so this is the remedy. Here we go. I called this the master graph for the female reproductive cycle, right? Let's say the master diagram, right? And in this diagram, it shows not a complete overview because it's not showing the what's going on at the level of the brain, specifically hypothalamus, and what's going on at the anterior pituitary, but it is showing the effect of the tropins, right, which are secreted by the anterior pituitary, and it's the tropins that have the effect on the ovaries. Just sort of a bit of a recap. Let's make that tropins. There we go. The fact that the egg develops, this is because of FSH. This is all about follicle stimulating hormone. Estrogen levels begin to rise because estrogen is going to be secreted, right, by these cells. All these cells right here start to secrete a lot of estrogen. And as estrogen levels peak near to ovulation, it's actually high estrogen levels that cause this, right? So there is a nudge on luteinizing hormone, right? Which is this one here. So your LH spikes because of high estrogen. And that makes a lot of sense because the LH spike, right, causes ovulation. And that makes a lot of sense. The egg is ready to go. It's time for the egg to be released from the follicle. So you can see that really high estrogen here, okay? Now, the estrogen has that additional effect. It's the estrogen that is building up the lining, right? So progesterone is coming from the corpus luteum, okay? So I'll just make a note there. And high progesterone levels maintain this phase. They keep you in this phase, which is why there's a lot of progesterone in a birth control pill, because the corpus luteum has got you locked into the secretory phase of the uterus, the luteal phase of the ovary. Okay, when those levels, right, when this fades at this point and it becomes a corpus albicans, right, this little thing, little popcorn-shaped thing, right, corpus albicans, right, that's it. And now the progesterone levels, they fall and the estrogen levels fall, and you'll see that dip. Well, that dip coincides with that. And at this point, there's nothing to hold back the start of the reproductive cycle. The mens will happen, which you see here, right? And the cycle begins again. So as far as the sex hormones we have to focus on, specifically to sort of finishing this lesson, estrogen and progesterone are very much the ovarian hormones. So let's put a little note there, right? Those are the ovarian hormones. And let's use orange, right? The tropins are not the ovarian hormones, right? Estrogen and progesterone are. So they are going to cause sex characteristics, right? They maintain the uterus. They're in charge. So the secondary sex characteristics, the body hair, the fat deposition, the widening of the hips, pelvic girdle, breast development, right? That is all due to these hormones. Now, we've been talking about the overall cycle that's going on. In females, one cycle that has to be considered is fertilization. If an egg is in fact fertilized, right? That is called conception. So we'll just draw a little big egg, right? Like this. We'll draw, of course, not to scale. Army of sperm digging their way in. Although only one ever makes it in, right? To deliver the male pronucleus, right? Containing 23 pairs of chromosomes in this case, since we're talking about humans. It has been thought that women ovulate, just like one time per month, but humans aren't digital. We're analog organisms. So we have patterns. We're continuously changing, but these patterns aren't They're not absolute. So there can be multiple ovulations. Now, I had a student point out to me, hey, a study of 63 women, that's not a huge study, but there is multiple ovulation happening rarely in the female population. But if you look at a big enough population, then it's not rare. Diamonds might be rare, but they're forming and they're found all the time. So evidence of multiple ovulations, you don't have to look much further than fraternal twins, right? That's 2 eggs, 2 sperm, if we're just talking about 2 twins. Identical twins are a little bit different, right? That's when the developing ball of cells splits and you actually get clones. You have 2 chunks of an organism and they both grow up, right? So the thing about ovulation is the best sort of outlook on this, I think it's fair to say, is you have to consider that ovulation, it doesn't just happen once a month, it can happen at different times. And to safeguard your reproductive health, right? And just decide to have children when you decide to have children, that's completely up to you. Assume fertility is an option, right? Take steps because it's your life. So it's your reproductive health, it's your reproductive future. So assume fertility and take steps to conceive when it's up to you. Okay, here's an interesting little factoid. If you look at the ovary, so we'll draw an ovary kind of like this, there is a structure called, a lot of people think that the ovary is hooked straight up to the oviduct, but it's not in humans, okay? There is a structure, which I'm drawing so campily, right? These are the fimbriae, these little finger-like projections, right? And here, this, right, that is the oviduct, also known as fallopian tube. So if an egg is released, that egg could actually be lost. It can even be lost into the body cavity. That egg is sort of swept in. The fimbriae sweep over it, and they convince the egg to enter. And then there's these little cilia, these just little hair-like things, right, which I'm drawing kind of finely, and they help the egg to move down the fallopian tube, right, in that direction. Now, it is possible for an egg to get stuck, and if the egg were to start developing, that's not good, because if you can't come to term, a placenta, there's not enough room to grow. And they call that an ectopic pregnancy. And that has to be, it's not transplantable for the health, for the life of the mother, and the embryo is not going to be viable anyways. It has, that pregnancy has to end. One of the symptoms of an ectopic pregnancy is a lot of pain. It can radiate upwards into the jaw, fainting. There's a great number of symptoms, but if the egg is stuck there, there's no way to get it moving. Really, that egg, once fertilized, it has to get to the uterus and it has to form a placenta fast to be viable. It just won't survive if it doesn't. So what happens at this point? A lot of people get this wrong, and fertilization doesn't happen in the uterus, so let's extend the oviduct. In about the upper third of the oviduct, that's when the legion of sperm are supposed to come swimming in, right, to fertilize. One sperm does fertilize the egg, but it takes a legion of them to chew through the outside of the egg, right, which has got, I should probably choose a color you can see, right? The egg has a slime layer, which we'll look at in more detail later, but the sperm literally have to burrow through it to get in there to fertilize, right? So fertilization happens in the upper third. Then once the egg is fertilized, it carries along the cilia, sweep it down until it enters the uterus and implants. So pregnancy, within 5 to 10 days, really what you're looking at for the cells is the cells begin to divide, and it'll go through a process called gastrulation. But without getting into gastrulation, you just have to understand that what's happening is the outside of the organism is forming. And then the inside of the organism, right? Its endoderm is going to form. And then its mesoderm, right? The area in between that I'm shading kind of, right? All these germ layers have to form. So I'll go ahead and label that, right? Let's use the colors, right? This is the ectoderm, right? You've got your mesoderm here. Yeah, I got to stick with that. Mesoderm. I'll draw a little X, a little dot on it so you see what I'm pointing at. There you go. That's the mesoderm, right? Where you find your organs and the hollow space where your organs fit. And this green part, right? We covered this in Bio 11. That green part right there, I'll put a little black X on it so you can see exactly what I mean. Yes, that is the endoderm, which is your food tube that goes through your body and comes out the other end. Endoderm. There we go. Derm for dermis. Okay. So at this point, this ball of cells will travel down and it'll implant. So at this point, I'll update this. This is an old slideshow. So for the purpose of this recording, I'll say the individual or the person, right, is pregnant once implantation happens on the uterine wall. At this point, the placenta can now produce something called HCG, which is named after a tissue in the placenta, which is the chorion. So you get human chorionic gonadotropic hormone. So I've actually seen that written as HCGH. I would accept either abbreviation. And HCG, what it does is it keeps the corpus luteum around. Yay, corpus luteum. The corpus luteum endures and it helps you keep you locked into that day 15 through 28 so that the pregnancy can be maintained because you need the thick uterine lining. You don't want the tropins to start up again. That would be disastrous for the pregnancy because the body would enter the menstrual part of the reproductive cycle. So you can detect HCG. In fact, that chemical is what is present in urine, and it's only there if the person is pregnant because there is a placenta. Right? It's the placenta that makes it, and only the placenta, right? So the placenta makes this stuff. And modern tests are surprisingly accurate at detecting the levels of HCG and estimating how long or how far along a person is in their pregnancy. Okay, so once the mass of cells kind of tumbles out, right, comes tumbling out, there's many places it can implant. It can implant here, which is nice and high, but that mass of cells, and I'll just kind of draw it like this, right? That mass of cells can actually implant down here and then the placenta will start developing, right? And the thing about the placenta, if it's low-lying, a placenta can actually cover the cervix, and that's called placenta previa. And the baby can't be born, right? That blocks the baby from being born vaginally. So at that point, you're looking at a cesarean section, also known as a C-section, right? Low-lying placenta. So in this graphic, what you have here, just put an X, there's your embryo, and behind it, pick a more neutral color, gray shows up better. There's the endometrial folds, that's the endometrium in behind. Well, it's been denoted here, but it's all this other stuff. Endometriosis, you might have heard of as a condition. Endometriosis is excessive growth of endometrium. And just drawing it, it can actually build up, it can even block fallopian tubes. And it doesn't just grow inside the uterus, right? Or the reproductive tract. It can actually get outside. And it can, can be a very painful, to say the least, condition. And in some cases, requires surgical intervention, right? So, just sort of recap, the placenta starts making the HCG and it keeps the corpus luteum around. So we kind of mentioned that. It's a little redundant. I apologize. But that corpus luteum is kept around. So we'll make that hot pink. There we go. Until the placenta starts cranking up its own really high level of production, right? And it can crank out some really high levels of estrogen and progesterone. The levels of estrogen are responsible for the morning sickness, right? So I'll make a little note that, right? But it's a bit of a misnomer because it doesn't just happen in the morning, right? Morning sickness, it can happen all day long. It's just really toxically high, well, not toxic, but really high levels of estrogen, right? And that's what causes that. So if a person is pregnant, there's a couple of items listed here. It's not a comprehensive list, but menstruation would cease because you're kept in the latter half of the reproductive phase, right? Which is the luteal phase at the ovarian level, and you're in the secretory phase at the uterine level. There will be an increased size breast tissue. That tissue starts to down the road, considering what it's going to be doing, right? The lactation, the production of milk. So mammary tissue is going to become quite active. And darkening of the areola, on the breasts, is another thing that can happen. So menopause, sort of last part of the lesson here, sort of concluding. Perimenopause can be anywhere 40-ish, right? And it develops. So it's a little confusing for some people what's going on, but the brain is producing FSH and LH, so that's still happening, right? It's almost like the brain is producing the tropins, but the conversation isn't being listened to properly, right? So the ovaries, in this case, are not responsive to the tropins. And what happens if the ovaries aren't getting the message, then they produce less estrogen and progesterone, right? And at that point, what we have is a condition, right? Right here, where without those floating around in the blood in the same concentration, you'll get these symptoms: hot flashes, vaginal dryness. It can even include a bit of thinning of the hair, insomnia. It can have an effect on mood, such as depression, right? So there's physical and psychological symptoms to consider, right? So menopause, because we're analog organisms, you cannot put a stopwatch on this. This isn't digital. You can't say exactly when it's going to happen. What is interesting is if you do something called hormone replacement therapy, right? HRT. Hormone replacement therapy is an option, but what happens if you try to put higher levels of hormones back into the blood, it can cause an increased risk of cardiac events and strokes in females. And this also applies to males. If you crank up the testosterone levels, same thing. Increased risk of stroke, cardiac events, and strokes. So you would think that you could just replace what's not there, but it's not that simple. Okay, so I've kind of hit the end of the line here. Control of reproduction is covered in a lot of other courses. If you look in your Biology 12 textbook, you'll see it's there, but it was designed, this book is more general purpose, right? It's it's a very good book, and it covers a broad range of things. It's sort of pseudo-college in nature, and it provides all the details, right, as of its published date. The only birth control method that works 100%, absolutely, is to not introduce sperm to egg, right? So that's just a fact. If they can't get together, the two haploid cells, right, can't merge the nuclei, right? So the idea is to just keep it apart, right? They don't meet. Every other technique is about trying to ensure or to influence that process, from birth control to the diaphragm, the sponge, the condom. There's a female version of the condom. I cover these all in class because it's the tail end of my lecture. That's my live event, right? So I'll leave it at that. But there is a table, right? If you look at this table of methods, right, and you see birth control right down here at the bottom, abstinence is the only one that is going to give you 100%. Right? So, and one of my students asked about family planning. Well, family planning is when you decide to have kids, right? So there's many reproductive methods that can be used. Vasectomy or tubal ligation, without getting into it, they're not 100%, but they're pretty close, because you're preventing sex cells from even getting right to meet, right? In this case, cutting the vas deferens, right? So that they can't get out. Well, right? Was that a perfect process? There can be mistakes. It can happen. The same thing with the tubal ligation, which is also referred to as having the tubes tied. But there are a great number of reproductive technologies, so it's worth it for you to check this out. And in class, we go over them. There's a great number of them. So, ladies and gentlemen, This was that last little bit that was missing from my notes. So there you go. And thanks for listening.